What if everything you believed about human skin color was wrong? That it was never race, only survival? Nearly 300,000 years ago, no cities, no medicine, only relentless sunlight deciding the fate of billions. Predators waited in the grass. The sun never relented. Survival here was earned, never simply given. Hidden inside their skin was a biological advantage that would shape the destiny of every human descendant. Fossil records and modern genetics agree. Homo sapiens began here, in Africa, under Earth's most intense sunlight. Under this sun, skin color was never cosmetic. It was chemistry, functioning as the body's natural armor.
That armor had a name: melanin. More melanin meant stronger protection against dangerous ultraviolet, or UV, radiation.
Melanin also protected something deeper than skin. It shielded DNA itself from radiation-driven, dangerous genetic mutations.
UV radiation can destroy folate, a vital B vitamin essential for healthy pregnancies and nervous system development.
Generation after generation, nature quietly favored the skin that survived best. Proof: biology simply keeping people alive. So the earliest modern humans were almost certainly dark-skinned, plumbed, not by choice, but by pure necessity. But humans are restless by nature. Curiosity pulled small groups northward, toward new land and horizons. They couldn't know it yet, but every step north led into a completely different world of sunlight.
As they moved farther from the equator, the sun grew weaker, and its UV radiation began fading. Less sun created a brand new problem. Dark skin, once a lifesaver, now blocked something the body needed. Sunlight helps the body produce vitamin D, essential for strong bones and a healthy immune system. So, once again, nature adjusted. Over thousands of years, lighter skin gradually spread across these populations. This was never about one race becoming superior, the same species adapting differently to different sunlight. Every skin tone alive today tells one story: generations of the human body adapting simply to survive. So next time someone asks why humans look different, remember, it was survival, written into skin.
What if one journey out of Africa reshaped how millions of humans would someday look? Forever. Could the very skin that once guaranteed survival suddenly become a disadvantage in a different climate? Around 6,000 to 7,000 years ago, small human bands began one of history's greatest migrations. These weren't armies or organized empires, just hunter-gatherers searching for food, fresh water, and safer ground. They pushed into the Middle East first, then gradually spread toward unfamiliar, cooler lands beyond it. Europe looked absolutely nothing like Africa. Longer winters, colder air, and far weaker seasonal sunlight overall. Central Asia's vast steppe brought its own extremes. Brutal winters and months of dim, pale sunlight. Some northern regions saw almost no direct sunlight for months, creating an entirely new evolutionary challenge.
Dark skin, so effective against intense UV, also blocked UVB, the exact rays the body needed. Without enough UVB, the body struggled to produce vitamin D, essential for absorbing calcium and growth. Vitamin D also supports a strong, healthy immune system, heated, critical for surviving long, harsh northern winters. People whose skin let in slightly more sunlight produced more vitamin D during long northern winters. Over countless generations, not just a few, but thousands of years premise, lighter skin slowly became common.
This wasn't planned, and not every population changed the same way. Evolution responded differently across every region.
Diet mattered too. Some Arctic populations kept darker skin, since their fish-rich diet supplied vitamin D naturally. So why don't all populations living at the exact same latitude share identical skin tones today?
The answer is hidden deep inside our DNA, in genes quietly shaping one of humanity's most visible traits.
A surprisingly small number of genes turn out to control most of human skin color variation.
In the next part, we'll uncover how mutations and natural selection built humanity's incredible skin diversity.
Every shade of human skin still carries this hidden history Forbes, written slowly across 6,000 years.
No magic, no sudden transformation foo, just microscopic genetic changes quietly rewriting human skin across countless generations. These tiny variations passed silently from parents to children, generation after generation, for thousands of years. Evolution never created better skin. It simply created skin better suited to different environments and climates. As humans settled across Europe, Asia, and beyond, natural selection kept reshaping their bodies to fit local conditions. Contrary to popular belief, there's no single skin color gene controlling this, and the truth is far more complex. Scientists discovered dozens of genes work together, each influencing melanin, pigment distribution, and skin's response to sunlight. Among the key players, SLC24A5, a gene strongly linked to lighter pigmentation in European populations today. SLC45A2 works alongside it, helping regulate how much melanin gets produced and distributed within skin cells. OCA2 and TYR also shape pigmentation, controlling enzymes that determine exactly how much melanin skin cells make.
Then there's MC1R, a gene famously linked to red hair, freckles, and certain lighter skin variations.
Together, these genes decide how much melanin skin produces, how it's distributed, and how it reacts. In Europe, lighter versions of these genes spread because they let more UVB reach the skin. More UVB meant better vitamin D production, a critical survival advantage during Europe's long, dark winters.
But this shift was incredibly slow. No single person ever changed color within their own lifetime.
Instead, tiny genetic differences quietly accumulated across countless generations until entire populations gradually looked visibly different. East Asian populations also independently evolved lighter skin through completely different genetic pathways than European populations did. Scientists call this convergent evolution, separate populations independently arriving at similar traits under similar environmental pressures. Near the equator, in Africa, Australia, Melanesia, South Asia, intense UV kept favoring darker, protective skin. These weren't separate origins, just different solutions to the same challenge, balancing UV protection with vitamin D. So does skin color reveal anything about intelligence or human worth? Modern genetics answers that question clearly.